I am Anil Kumar. Welcome to my series on advanced functions. We have questions here for polynomial equations and inequalities. These questions have been taken from previous test papers, and I hope your practice with these will help in getting better marks. I have carefully selected the 6 questions from different topics relating to polynomial equations and inequalities to give you a very good overview of this particular topic. We'll take up double inequality, absolute function example, increased volume application, strategy to solve polynomial equations, and we'll also extend when multiple functions are integrated. So let's begin with the very first one, which is question number 1 for you. Solve the double inequality 5 times x minus 1 is less than equal to 3x plus 7 is less than 8 plus 5 times x plus 1. At this stage, you can pause the video, answer the question, and then look into my suggestions. Let's copy this question once. It is 5 times x minus 1, which is less than equal to 3x plus 7, which is less than 8 plus 5 times x plus 1. So in test questions, you have to be very careful, right? One side we are using greater than equal to, the other one greater than, correct? Now let's expand and simplify. So we get 5x minus 5 is less than equal to 3x plus 7. So when I'm reading from left to right, the sign will be read as less than equal to. Perfect? Which is less than 8 plus 5x plus 5. Now, we should take care of the variables. 5x and 5x are additional variables on both the sides. So let us subtract 5x and 5x from both the sides. What I'm trying to say here is we'll do minus 5x, and minus 5x. So once you do that, what do you get? You get minus 5 is less than equal to, when you take away 5x, you get minus 2x here, plus 7 is less than 5x and 5x vanish, you get 8 plus 5, which is 13. Now we'll look into the center part where we have 2x plus 7. What should we do now? Well, we have to take away 7 now from all these sides. So when you take away 7, you are left with minus 12 less than equal to minus 2x, which is less than 6. Now, we have minus 2x. I have to divide by minus 2. When you divide by minus 2, then what happens? The sign has to change. You get the idea, right? The sign has to change. So I'll rewrite this saying minus 12 divided by minus 2, and look here, the sign changes, right? So minus 2x divided by minus 2, sign changes. 6 divided by minus 2. Perfect. So minus minus becomes plus, so we get 6 here is greater than equal to x, which is greater than minus 3. You get just the right signs. Do you see the importance? So if you're multiplying or dividing by a negative number, you have to change the sign of inequality. So that becomes our solution. Perfect. So we have our answer, and the answer here is that x is greater than minus 3 and is less than equal to 6. And that is how you're going to solve this double inequality. Let's move on and take the next question. Question number 2. Express minus 3 less than x less than 5 as an absolute function inequality. So we have to write the inequality as an absolute function inequality. How are you going to do it? So let's have a bigger picture of this. So on a number line, let's see what we have. Minus 3, let's say this is minus 3 for us, not included, so I'll make a circle. And let's say this is 5 for us. Somewhere in between here, we could have a 0. We want to include this inequality, which is everything in between these two numbers, with the help of an absolute function. Now remember, whenever we're talking about absolute function, in that case, we are looking for a center value. So what we have to do here is find the center value, so that we have an absolute function which is kind of like this, and then we can form an inequality which will look into everything in between these two values, right? So it is not drawn correctly, but anyway, so like this. Does make sense to you? That is what we are looking for. So the procedure here is, first step is to find the mid value. So which you can get by adding and dividing by 2. So minus 3 plus 5 divided by 2 gives you 2 over 2, which is 1. So the center value actually is 1. So let me just again draw the absolute function with 1 in the center. So now we get the correct one. Do you see that? Okay. So we get absolute function shifted to 1 unit right. So if that is the absolute function, I will rewrite this as absolute value of x minus 1. And we want to know how much far we are from the extremes. So that you can find distance from the extreme is what? So in this case, 5 minus 1 is equal to 4. And here, 1 minus 3 is also 4. So you are within a boundary of 4. So that is how you are going to get your absolute function equivalent. So that becomes your answer, right? So exactly, this represents the inequality minus 3 is less than x is less than 5. Did you understand these steps? So the last step which I did was, let me write down, find how far is the extreme from center, right? So that becomes your inequality. So that is your answer. Perfect. So this is a good question where the extremes are not the same numbers, they're different numbers. Let's move on and take the next example, which is question number 3. Here is question number 3. Anil has designed a rectangular glass house. His scale model has dimensions 1 meter by 2 meter by 4 meters. By what amount should he increase each dimension to produce an actual capacity that is 9 times the volume of his scale model? So you can actually pause the video, answer this question. Volume at present is 1 meter by 2 meter by 4 meter, correct? So when you multiply, 2 times 4 is 8 meter cube. We want this volume, the required volume is 9 times 8. That is what it means when you say 9 times, correct? 9 times 8 gives you 72 meter cube. So that is your new volume. We are increasing by x, let us say. Let's say increase by x each side. Okay, so in that case, the volume will be what? So let me use this space. So the increased volume is going to be equal to 1 plus x times 2 plus x times 4 plus x. So that becomes the increased volume, and it has to be 72. So that becomes our equation to be solved. Is that clear to you? Perfect. So we'll kind of expand this, simplify, and then get our answer. So let's multiply by 1 first. So we get 2 plus x, and then with x, we get plus 2x plus x squared, and then so we get the first part, and now we'll multiply this with 4 plus x, bring 72 to this side, equals to 0. Now this could be written as 2 plus 3x plus x squared times 4 plus x minus 72 equals to 0. Now let's multiply with 4 plus x. So 4 times 2, let's write down here, 8 plus 12x plus 4x squared, and then with plus x we get plus 2x plus 3x squared plus x cubed minus 72 equals to 0. That becomes the equation now. Okay, so let's combine the like terms, taking care of the highest power, x cubed, that comes first, and then x squared terms, we have 4x squared and 3x squared, that gives us 7x squared. And then the x terms, 12 plus 2, 14. Okay, so we get plus 14x. And then the constants, so 8 minus 72. So that gives us 64, right? 64 plus 8 is 72 equals to 0. So we have a cubic equation now, and let's see what could be the solution. So we'll try the values one by one. So if I substitute, let's say 1 here, what do I get? I get 7 plus 14, which is not the right answer. It doesn't give you 0, right? If I try 2, so we need a calculator at this stage to figure this out. So if I try the value 2, so let's say we try the value 2, let me use the calculator. So 2 cube is 8, plus 7 times 4 is 28, plus 14 times 2 is 28, and minus 64, that gives you how much? That gives you 0. So we do get a 0 for the value 2. So if I put x equals to 2, in that case, we do get a 0. So that works for us. Okay. So that means x minus 2 is a factor. So this particular polynomial is 0. So x minus 2 is a factor. Correct. So 2 could be our answer. Perfect. But anyway, let's also do synthetic division here on the side just to show that this is absolutely correct value. Okay. So I'm going to write down the coefficients, which are 1, 7, 14, and minus 64. And we'll multiply by 2, rather divide by 2. So bring down 1, multiply by 2, you get 2. Add them, 9, multiply, you get 18. And then when you add them, you get 2, and that is 32. And when you multiply, you get 64, and you see that the remainder is 0. Correct? So we get this as a factor. You could write this as x minus 2 times a quadratic equation, x squared plus 9x plus 32 equals to 0. Perfect. So you have written it in the factored form, and it clearly means that the solution is x equals to 2. Correct? Now the question is increased by, so by what amount should he increase each dimension to produce an actual capacity that is 9 times the volume of the scale? So we can now write down our answer, which is that each side should be increased by 2 and the units are meters. Is that clear to you? So that is how we are going to answer this particular question. Perfect. Let's move on and take the next question now. Here is question number 4. The polynomial 2x cubed plus 9x squared plus 4x minus 15 represents the volume of a fish tank in cubic feet. If the depth of the tank is x minus 1 and the length is 11 feet, calculate all the dimensions of the tank. You can always pause the video, answer the question, and then look into my suggestions. So let's begin by equating the volumes. We have the volume given to us as 2x cubed plus 9x squared plus 4x minus 15, and that should be equal to 11 times x minus 1 times, let's say f of x. We need to figure this out. So we can divide the left side 2x cubed plus 9x squared plus 4x minus 15 by x minus 1. So we get 11 f of x. Let's use synthetic division to divide. We have, write down to the coefficients 2, 9, 4, minus 15. We are dividing by 1, and yes, let's bring it down. 2 times 1 is 2, add them 11. 11 times 1 is 11, you get 15, and then we get remainder 0 as expected. So the quotient here is 2x squared plus 11x plus 15. We can factor this. 2 times 15 is 30. 6 times 5 can work for us. So we get 2x squared plus 6x plus 5x plus 15, which is 2x is common, x plus 3. Here 5 is common, we get x plus 3. And so we can write this on the right hand side. What we get is x plus 3 times 2x plus 5, right? That becomes the factor, and that has to be equal to 11 times f of x, correct? Now, one of these factors should be 11. That is what we're trying to say. So we can actually solve for different conditions. So we have two conditions here. If x plus 3 equals to 11, then x is equal to 11 minus 3, or x is equal to 8. And if 2x plus 5 is equal to 11, then 2x is equal to 11 minus 5, which is 6 divided by 2, which is 3. So we have two possible values of x. Is that correct? So we have two possible values of x. And now we have to give you the dimensions. It says calculate all the dimensions of the tank. Now what are the dimensions of the tank? Let's rewrite the dimensions. Dimensions of the tank are, we have x minus 1 and these two factors, right? So we have dimensions as x minus 1 times x plus 3 times 2x plus 5. So these are the dimensions, perfect? And we have two values of x. X is equal to 8 or x is equal to 3. Substituting, we get our dimensions. Let's put 8 first. So if I put 8 here, I get 8 minus 1 times 8 plus 3 times 16 plus 5. That is one set. Very less space here, so we have to manage the space. And the other one is Substituting 3 here, we get 3 minus 1 times 3 plus 3 times 6 plus 5. So the dimensions become 7, 8 minus 1, 7 times 11 times 21. The other one is 2 times 6 times 11. So 11 is in both. Do you see that? So these are the two possible answers. So we get our answer, and the dimensions are 7 feet by 11 feet by 21 feet, or 2 feet by 6 feet by 11 feet, correct? So that becomes the dimensions of the tank. Well, these will give you different volumes, but when you substitute the value here for x, you'll get different volume too, right? So basically, we are working with x equals to 8 and 3, which gives you these two solutions, and those are the right answers for this particular question. Now, this question has been in test paper a couple of times, and very few students have answered it yet. Okay, next question here is question number 5. My grandchildren, Nirvan and Akane, are running around in a park. Their position in meters with time t in minutes can be modeled by the function nt, this for Nirvan, t cube minus 6t square plus 28t minus 10, and at, which is for Akane, t square plus 14t minus 2, respectively. How many times in the first 5 minutes do they cross one another? Justify your answer. So basically, whenever they cross, we get the same position value. So again, it's an example of polynomial equations. Let us see how to do it. So we'll actually equate the Nirvan displacement, which is t cube minus 6t squared plus 28t minus 10 with Akane displacement, which is t squared plus 14t minus 2, right? So the reason being that whenever they cross, at that time the position of Nirvan and Akane should be same. So that is the reason. Now let's try to simplify, bringing all the terms together. We get t cube minus 6t squared minus t squared plus 28t minus 14t minus 10 plus 2 equals to 0. So we have t cube, that becomes minus 7t squared, and that becomes plus 14t, and this is minus 8 equals to 0. So again, we have a cubic equation. We have to try different values. So let's try what happens for t equals to 1. So if I write t equals to 1, we get 1 minus 7 plus 14 minus 8, and that is 1 minus 7, 15 and 15, that is 0, so it works. So we know that now we have one solution, which is t minus 1 is a factor. So again, we'll do synthetic division and get our answer. Let's write down the values given to us. So we're dividing by 1, and t coefficient 1, then minus 7, we have 14 and minus 8. These are the coefficients. Bring down 1, multiply, add them. So we get minus 6, write minus 6, add them. So we get 8 and write 8, and as expected, you get 0. So we get our quadratic function here. So let me make some more room and write down minus 6 very clearly, right? So let's write down the factors on the right side to get the other factors. So we could write this as t squared minus 6t plus 8. And now 8 4 times 2 can work. So 4 times 2, both negative. So t minus 4 times t minus 2. So that works. So what we get here is basically t minus 1 times t minus 4 times t minus 2 is equal to 0. That gives us t equals to 1, 2, and 4. All these values are less than 5, and so they are relevant answers. Perfect. And we get our solution. Our answer here is, see, the question here is very important to understand. It says how many times in the first 5 minutes do they cross one another? So our answer is 3 times. Right? Those are the 3 times when they cross after first minute, second minute, and third minute. However, the answer should be of they cross 3 times. So 3 times they cross. Perfect. Let's move on to the next question, which is also the last question. Question number 6. Write a linear function g of x such that it is greater than f of x equals to 5 minus x squared when absolute value of x minus 1 is greater than 2. Wow. So this is a brilliant question. We have a couple of functions here. So we're looking into 3 types of functions. We have a linear function, we have a quadratic function, and an absolute function. We have to combine the concepts learned about equations and inequalities to solve it. So it says write a linear function g of x such that it is greater than the quadratic function, which is kind of a parabola moving downwards, when x minus 2 is greater than 2, x minus 1 absolute value is greater than 2. So we have to find this interval. Okay, so we can begin with the absolute value of x minus 2 greater than 2. So we should solve this. So that really means that it could be written in 2 parts, right? So whenever you do absolute function inequalities, they can be split into 2 parts. So one is when it is positive, x minus 1 is greater than 2, and the other one is negative value. So we have x minus 1, which is less than minus 2. Now these two values, plus and minus, are in a particular interval. This is when x is greater than equal to 1, and this is when x is less than 1, right? It comes from here. So you have to rewrite the absolute function as a piecewise function to begin with. Now we can solve this to get the interval. So x is less than minus 2 plus 1, x is less than minus 1. On this side, x is greater than 2 plus 1, or x is greater than 3. So we get our interval. So basically, the interval in which we are interested is away from minus 1 and away from 3. So within this interval, write a linear function g of x such that it is greater than the given function. So think like this. Let me sketch. So what we're trying to do here is that we have a parabola which is moving downwards, kind of like this. And we have a linear function which is greater than this parabola in the interval beyond, on the left side, minus infinity to minus 1, and on the right side from 3 to infinity. That means if we have something like this, we are looking for an interval which is this. Do you see that part? Perfect. So we are interested in finding the points at which it intersects the parabola. Only then we get our solution. Is the concept clear to you? Correct? So we have 2 critical points to work with, and at these points we are now going to find the value on the parabola. So one is x equals to minus 1, the other one is x equals to 3. So f of minus 1 is 5 minus minus 1 squared, which is 5 minus 1, which is 4. And f of 3 is 5 minus 3 squared, 3 square is 6, and so we get minus 1, right? So these are the two values. So we get our point, which is one coordinate point is the value here. Let's rewrite these values. So the point here is when x value is 3, the y value is minus 1. And in this case, when the x value is minus 1, the y value is 4. So those are the 2 points. Now we are interested in finding the linear function. Perfect. Do you understand? So now let's find the linear function. So linear function, which is going through 2 points, let's call them A, which is minus 1, 4, and B, which is 3, minus 1. Does it make sense? We're calling this point as A and the other one as B. Correct? So that is what it is. Now we can find the equation of line and we get our function. Perfect. So let's find the slope. Slope m will be change in y value. So 4 minus minus 1 divided by minus 1 minus 3. Or we get 5 over minus 4. So change in the y value, basically we did what? Slope is delta y over delta x. So that's what we did. Change in y value, 4 minus minus 1 and minus 1 minus 3. So we get 5 over 4 as the slope. And the equation we can write in the form of y equals to y minus y1 equals to m times x minus x1. So we have y minus, let's use this value, 1 and 4. So we have y minus 4 equals to the slope 5 over minus 4 times x minus x1, which is plus 1 here. So we can just cross multiply. So we get minus 4y plus 16 equals to 5x plus 5. And now we can bring them together to write down the equation of the line. So we get here 5x minus 4y becomes plus 4y. We have plus 5 and plus becomes minus 16 when you bring it there. It's a very tricky question. And you get your equation. So we have 5x plus 4y and minus 11 equals to 0. So that becomes the equation of the linear function. Is that clear to you? So our answer here is that the line is 5x plus 4y minus 11 equals to 0. Perfect. So I hope you enjoyed this journey of learning along with me how to solve equations and inequalities. The questions taken here are from previous 5 years, the best questions, right? So I hope you have learned a lot in this process. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.